Hello everyone. Today is the 65th day of Leetcode 75 challenge. Let's begin with the 65th question. Question 714. Best time to buy and sell stocks with transaction fee. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given an array prices. The prices of I represents the price of a stock on that particular day or ith day. Okay, you are also given an integer fee which represents the transaction fee for each buy plus sell operations. Okay, so suppose if you are given this array, okay, prices, and if today's price of stock is 2 and then it's 7, then again it's 1, then it's suppose 1 again. Okay, so if you buy this stock at this particular price and when you sell it when the price of the stock is 7, your profit is how much? 7 minus 2, it's 5, right? This is a profit, but they have also included a transaction fee. Okay, suppose the transaction fee, if suppose transaction fee is 2, so then from 5 2 will be subtracted, so your profit will be 3. Okay, so you can complete as many transactions as you like, but you must sell the stock before buying again. You can only hold one stock at a time. Okay, suppose if you buy this 2, you cannot buy 7, right? You have to sell the 2 first, and then you can buy whichever stock is in a further array. Okay, so for every buy and sell transaction, the transaction fee is subtracted once when you sell the stock, which we already understood. Your goal is to maximize the total profit you can achieve by making valid buy and sell decisions across the days. Okay. You must return the maximum profit that can be earned after completing any number of transactions with a given fee. Okay. The note part is that you may not engage in multiple transactions simultaneously. You must sell the stock before you buy again. The transaction fee is only charged when the complete buy and sell of a particular stock is done. Okay, so you have to basically return the maximum profit you can get after trying out all the possible ways. Okay, please focus on this line, all the possible ways. Basically it's saying across the days, right? I will explain that later. So I hope you understood the problem. Now the constraints of the constraints says that prices length could be from 1 to 5 into 10 to the power 4. Prices of I value could also be from 1 to 10 to the power 4, which is multiplied by 5. And the transaction fee will be also from 0 to 5 into 10 to the power 4. Okay, the problem is pretty straightforward. So let's go to the next slide. Now let's understand the input output explanation. Fine. So let's take this example first. 1 comma 3 comma 2 comma 8 4 comma 9. Okay, you bought one, okay, and sell. Let P be the profit and let this be the total, and we know the fee. Okay, so by visually we can see that if we buy one and if we sell it here, we will be having the profit of 7, right? And 7 minus 2 gives me what? Gives me 5, correct? So 2 is the fee, correct? So after buying and selling of one complete transaction, we have the profit of 5 and the total 5. Okay, then from here if I buy this 4 and if I sell it at 9, my profit will be how much? Selling price is 9, buying price was 4 minus the transaction fees. This 6 minus 9 gives me what? Gives me 3, right? So this is my profit. So I will add it to my total. So it gives me 8. Okay, so this is how we got 8 as the output. Similarly, let's look at this example here. B is buy, S is sell, P is the profit, T is the total. Fine. So if we see here, if we buy one, okay, and we sell it, if we can see here, if we sell it at 7, we get a profit of how much? We get a profit of 6. 6 minus 3, which gives me 3, correct? So total remains 3 and the profit is 3. Great. Now from here if you can see, but if I buy at 5 and sell it at 10, let's try. If I buy at 5 and sell it at 10, the profit remains 5 minus 3, right? So 10 minus 5, this is totally 8, right? So this sums up to 8. 8 minus 2 gives me 8 minus 10 gives me 2, right? So if you add it to the total, it is 5. So I can see that output is 6, not 5. So there could be another way. Let's look for the another way. Okay. What if you buy it at 1, okay, and sell it at 10? What is my profit? It's 4. 10 minus 4 gives me 6. So my total is 6. So here output is 6, right? So yeah. So we from here we observed that there is not only one single way, right? We have to try all possible ways of getting the profit. Okay, I am hoping that you're guessing the thought which I'm trying to explore here by saying again and again the same word. So I hope you understood the input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Okay, so let's start by first understanding the goal. So we are given an array prices where prices of I is the price of a stock of I the day. Okay, we have the understanding of this particular thing. Now we also are given transaction fee that is applied once per transaction. Okay, so basically if you buy a stock and then you sell a stock, the complete profit minus the fee. Okay, and our task is to maximize the total profit. Okay, now however we cannot hold more than one stock at a time. We must sell before buying again. Now in the previous example, if you have observed, we have tried multiple ways, right? Because we are not sure what could be the proper transaction path to get the maximum profit. So for that, since we have to try all possible ways, this problem sums up to the topic of recursion. Very simple and straightforward. Okay, but in that we have two options, right? How recursion? Let me tell you. Because suppose this is the array, right? And if you're standing here, either you will buy this stock, okay, or you won't be buying. You will just come here, right? So you will buy or you will not buy. Okay, two ways. Okay, suppose if you have bought something, then suppose you have bought already. Now you have to sell it. So if you came here, either you sell it or you don't sell it and sell. Okay, so here also for buying you have two options and selling you have two options, right? So you have to explore all the possible ways here. Okay, so that is why this problem boils down to a recursion problem. And now since recursion will take a lot of time complexity, or we can say exponential time complexity, so we have to reduce the time complexity, right? And to reduce the time complexity, there is only one possible way of using dynamic programming. Okay, so I hope you understood the goal. So let's move to the next slide. So let's visualize this process now. Before visualizing, we should let me explain you one kind of a simple concept. Suppose you are having 10 rupees with you or $10 with you, whatever. Okay, or instead of putting currency here, let's say you have 10 units with you. Okay, suppose this is a cash to buy stock. Okay, so if you have 10 units, so the maximum amount of stock you could buy is of rupees 10, definitely. So if you buy a stock of rupees 8, this 8 will get subtracted from the 10, right? Or okay, first 10. Okay, 10 minus 8 gives me 2, right? So I am remained with the 2. And suppose you sell this stock and you gained a profit of rupees 4. Fine, so this 4 will get add to this total amount units you had, right? So it will become 6, definitely. And suppose, so this means that when you are buying something, or when you are trying to buy a stock, that is getting subtracted from the profit. Answer of I, I'm just writing answer of I, this will be prices actually. Okay, P. Okay, so this is what's happening, correct? So this is the one thing I wanted to explain. So uh, let's start the visualization process now. We move day by day, right, from index 0 to the last index. Suppose this is the array given to you. Let me 2, let make me some profit. 4, let me have some loss, then let me have some profit. Okay, great. So at which index we are in one of the two states? If you can focus, if you're standing here and you haven't buy anything, okay, so you have two options with you. Either if you can buy this, or you cannot, or you don't want to buy this, you will just move ahead, right? So basically there are two options. Great. Either you could not take it, or you could take it. Great. Now break it. Let's break it down. Now if you remember, we have to find the maximum, right? So what happens if you take the buy? What will happen? Suppose if we had the amount profit with you from this. Suppose let the array name be price of I. Okay. So this is going to be subtracted. You can take it in a that you can take it in that way, right? Suppose if you had 10, then this was of rupees 3, not rupees, let it be stock price of 3. Okay. So when you come back after the function calls, this will get subtracted from the profit, right? Makes sense. Okay. But if you don't buy it, what will happen? You will just move ahead, let it be index plus 1. And here also, uh, if you buy the stock, right, after that you will of course go index plus 1. Okay. And if you don't buy, you will just go index plus 1, and nothing will be added with the p of I. Okay. Makes sense. Great. Now let me write it properly. So we understood something roughly about buying. Okay. Now if you sell it when buy is 0, that means you're selling it. Okay. Again, in selling also you will be having two conditions. Okay. We will look at that later part. First, let us understand what happens when we can buy something. Okay. You have two options: either you buy the stock or you skip the buying, which I already explained you. What happens if you buy the stock today? We spend the money. That means subtract the current price, right? Definitely. So let me write it as a function. Okay. Suppose we'll subtract it from the current price of index. Okay. Plus, you will be calling some function, and you will go ahead with index plus 1, 0 comma index plus 1, right? Now you will be thinking why I have done this. Suppose if you have bought a stock today, right? You had rupees. Suppose you had 100 rupees with you, or you could call it as a profit. Suppose you have 100 profit with you, and today you bought a stock of amount of rupees 20, or units 20, or stock price of 20. So that will of course will get subtracted from the total profit you had, right? This is the profit amount. Okay. So because every time when you go ahead with this part, suppose imagine this as this way in a tree structure. Suppose you are going this way down the line, right? Until and unless a base case is hit. So what happens? You bought it here, it's 2, and you gain some profit here. Then you have bought something here, you gain a profit of something here, right? Now when you go back, what it is 9, right? Then you go back, it is 8. 8 plus 9 is how much? It's 17, right? When you go back, it's subtracted 2, so 15 is the total profit with you. Make sense now? Great. Now what if you don't buy? If you don't buy, it's simple. 0 plus, and you just move ahead. That's all. Or you will do anything, right? You are not buying anything here. Now, now these are the two ways which you are exploring, right? Therefore, there could be one scenario with this when you take something, and another scenario when you take this one, right? This might return this will be returning a value, and this will also return a value. And out of these two, which is the maximum, we have to look into it, right? So that is why we will try to take the maximum of this two. Okay, clear? So I hope you understood the buy part. Okay, now let's understand the sell part. Now, when the value of buy is 0, that means we have to sell, or we must sell. You don't have any other option with you. Now, what are the two scenarios? What comes to your mind when when you have to sell, right? Option one is either you sell the stock or you just skip selling. Basically, you hold the stock for future need, so that if you can make a greater profit out of it. Okay. So we earn money. So we add the current price. Let me explain this to you now. Suppose this is a price array. Okay. And you know that you are selling today, right? You're not subtracting because buy is 0. So this has to be added. This is the profit. You could call it as a profit. Okay. We earn money, right? So we add it to the current price. Whatever we have, we add it to it. We do the minus fee. Of course, because when you sell, when buy and sell, when you sell it, we know that according to the question, when complete process is done of buying and selling, we have to subtract the fee which is given to us. So this is what is done, right? After that, we try to call the function with index plus one. After selling, we just move ahead, right? Pay the transaction fee or subtract the fee, basically move to the next and make the buy one. Yeah, this I didn't explain earlier, but I will explain it. So when you sell something, that means that you are open to buy, right? Here also, if you remember, when you buy something, then buy will become zero, which means that you must sell in your next step. You cannot buy. Okay, fine. So this is done. So this will get, since we are selling it, so this will get added to our function. This is our earning money. Fine. If you don't think of selling it, just moving ahead, so it will be 0 plus the normal function call with index plus 1. Correct. Now again, same scenario here also. Since this will result in something else kind of a value or different value, and this will result in some different value, we need a maximum of these two values, right? So we will do max of both of them. Fine. So we understood how selling is going and how buying is going, right? So this recursion structure ensures that from each state, the index and the buying option 0 or 1, we explore the best future outcomes by branching all into all possible decisions, right? And since for this we have to have the DP. So before going to the DP, we should have the understanding of the recursion tree, right? And also before that, we understood the main recursion call, but what could be the base cases? We haven't discussed the base cases till now, right? So definitely the base case would be if the index, if it reaches to the length of the array, right? But so we will just return 0 from there. Fine. That will be our base case. So let's begin with a dry run. Let's take a smaller example. Suppose we have prices 1 comma 3 with us and the fee is 1 for it. Fine. So if we just start, remember it's index and buy. Okay. And also let me write it down. If we are buying, it is like we, this was the function call, right? Function is called, if you're not buying, it is just 0 plus function call. Definitely if you're selling it, it's price of I plus the subtract the fee and then plus the function, right? And if you're not buying, it's just 0 plus function. So this is for your reference. Great. Let's check the recursive tree. So if you just start with f of this is 0, this is 1, right? Definitely. So 0th index and 1 means we are open to buy. Now what if we buy? If we buy something, it is like 1 comma 0, right? Index increased. Now we have to only sell, that is why this becomes 0. Then what will happen? If we have buy, it will be minus of p of I, right? What was p of I? It was 1, right? So it will be minus 1. Fine. What if we skip it? If we skip it, it will be 1 comma 1 plus definitely 0. Now here we have two options: either sell it or don't sell it, or move ahead, right? So what happen if you sell it? If you sell it, we are at index 2, right? And with the option of buy, but it will be plus plus. Please look at here. Plus what? Plus. So if you sell it, it becomes, this is what? This is 3 and fee is 1, right? 3 minus 1 is 2, correct? So we will be having 2 here, and this is the end call, because we have already reached our base case. If the length of array, or you could say that if index, if I, let's say I is equals to the length of the array, we just return 0 from there, right? So yeah, great. Then if we skip it, this 2 comma 0 with plus 0, definitely, right? This call is done. Now for this we have two options: either we can buy. If we buy, we come to 2 with only selling option with, since it was index 1, so it will be minus 3. Or if we don't buy again, so it will be 2 comma 1 plus 0, correct? So this will return 0, and 2 comma 1 is written 0 because it is a base case. Okay, now if you see from here, the maximum of 2 and 0 is what? It is 2, right? So 2 is returned from here. Maximum of minus 3 and 0 is what? It is 0, right? So 0 is returned from here. Now 2 gets added to minus 1, so it becomes 1 definitely. So what is the maximum of 1 and 0 from this side, right? It's 1 definitely, right? So from here 1 will be written, so our output becomes 1. Okay, that is why for 1 comma 3, if we check, it is 3 minus 1 minus the fee gives us 1. So I hope you got some idea about how the recursion tree will be created and how we will move ahead, right? So now let's see how we can simulate this. So we will define a recursive function which will be having index buy. Buy means 0 means you cannot buy, you have to sell. 1 means you are allowed to buy. Then prices array, the fee and the DP which will be created. Okay. Now one more thing. So now we can also see the base case will be index, or index if it is equals to the length of the prices. Please return 0 because we are out of the bound basically. Okay. And for memoization, there is a check. If you remember, if this is a very famous check for the DP, if DP of index of buy, and you will be thinking why we are having 2 DDP here. Let me explain you why. Because in the function, we index is getting changed, right, and buy is also getting changed each time, correct? So that is why, since two parameters of the functions are changing, by keeping that in mind, this DP is of 2D DP. So this is the way how we figure out whether the DP which is going to be created basically depends upon the parameters which are getting changed every time, right? So if only one parameter is changed, it will be 1D DP. If three parameters are getting changed, suppose we're buying also, and index it is getting changed also, and some extra thing is also there, right? So it will become 3D DP. Okay. Now we will have one. Then after that, putting that into the base condition for the memoization, we have one thing, right? We will have a if condition, if buy, if it is equals to 1, which means that we are allowed to buy, right? So in the profit variable, we will be calling max of two things. One is if we buy, we'll call this, and if we skip, we will be calling this definitely, and we'll do the max of that. Okay. Else, if buy is 0, that means then in profit variable, we will be having max of sell, or then this equation, if we are holding, we are not selling, and then this max of both of them, the both of those basically, right? And after that, when this call is done, definitely at DP of index of buy, at that particular scenario, we will store the profit. This basically means that when index was 2, suppose, and buy condition was 1, which means that you're allowed to buy, in that particular scenario we have the maximum profit as this. Okay, got that? So what we figured out? We figured out that a problem has repeated subproblems. So we use dynamic programming to avoid recomputation, right? And when we buy, we subtract the price because buying costs money. Think it, if you're getting confused now also, just think it as the way I explained earlier. Suppose you have zero amount of money, right? But virtually you can buy something, so that cost will be subtracted from your profit, right? Suppose not, it is not zero, it is 100, right? So that will be subtracted from that definitely, right? It is the same thing. Just take it in that particular scenario. And when we sell, we add a price minus a transaction fee, right? And when you sell something, suppose you buy 100, you had 100, right? And you buy a 10 rupee chips. Okay, so you are left with 90, but you sold that 10 rupee chips at 15 rupees, right? So the difference between them was 5. And suppose the fee was 1, so it got subtracted. It was 4, right? So this will get added to your 90. So the total profit you had is 104, correct? So this is the way the thing works. So 4 rupees is your profit. Fine. So I hope you understood the intuition explanation. I know it was a pretty tricky one and a longer one, but now let's move to the next slide. Now, since we got the intuition of the problem, let's look into the approach how we're gonna solve it. So we are starting with the recursion preparation, right? So what that means is that in the main function, we will which is basically max profit, where we have prices and fee given to us. We will try to create a DP which is 2D array, and how it will look like? It will look like something this: -1 for dash in range. What will be the range? It will be 2. Why? Till the time I complete this, please think of it. And after that, this is the inner range. The outer range will be for dash in range n. Okay. Why this is 2? Because you have two options: buy. If it is 0, you cannot buy, you have to sell, or buy equals to 1, right? So the 2D array basically turns out to be kind of something this way: uh, two rows and multiple columns, 0 and 1 for buying and selling. Fine. I hope you understood that. After that, we will call a helper function which will passed with function 0. This is not 0, this is the index. Fine. This one is the buy equals to 1, which means that first step is, of course, you have to buy something, right? Then the prices, then the fee, and then we will pass the DP array there. We start from the day 0 with permission to buy. That function will recursively calculate the maximum profit from that point onward. Okay. Now handle the edge cases. In the main function, suppose func is our helper function, right? Here we will have the base condition: if the index is equals to the length of the array, please return 0. Okay. After that, now coming to the memoization, which is basically the main function in this func here. If you can see, we wrote the index: if it is equals to the length of the array, we will return 0, right? Then there will be another condition: if the dp of index with the buy, if it is not equals to -1, which means that you have already figured out an answer for this particular scenario, so please return this only. Okay. Then after that, we will have option: if buy, if it is 1, right? Then in the profit variable, we have the option of taking max, take, or don't take, move ahead. Okay. This is what it is written here: if y is 1, we take buy the stock. By doing this, you can see the formula here: max of the price took, right? You bought it, you didn't bought it, right? Similarly, if y is 0, in the else case, definitely the profit variable, we have the same scenario that if you sell the stock, this is the thing: if you sell the stock, please subtract the fine from the profit. Okay. And if you don't sell the stock, please move ahead. Okay. And after that, when this condition is done, at dp of index of buy, basically suppose at index 1 buy is 0, the profit was this much, so we return the profit. Okay. Why we are returning the profit after writing storing it in the db? Because we got the profit for this particular scenario, right? Now please go back so that we can get the profit for the other scenarios also, right? That is why. And the final output in the main function, definitely this function was called, right? So this will be returned as return of function 0 comma 1. Suppose dp was there, price was there, fee was there, right? So this is what this will return our final output. Okay. So I hope you understood the approach explanation. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. Okay. So I already talked about how the dp array will be initialized. So this is the dp array. We call the helper function. This is the base condition, of course, when we are out of bound. Suppose this is 0 1 2, right? But the array size is 3. So when we are 3, that means we are out of the array, so we return 0. This is the dp case, that if this scenario is already visited, please go back, don't do anything, just return the value from there. Now we have the buy option, and then the else, which have the sell option. Then after getting the maximum of it, we store it in the index and we return this particular profit to the previous calls. Okay. So for this particular code, the time complexity comes out to be 2 into n. Why the time complexity is 2 into n? Let me tell you. Let's take simply. Okay, n means what? N is the total traversing time of the array. And since it's a 2D what is the size of by? It is 2, 0 and 1, right? So it is n into 2, twice n, correct? And space complexity also takes twice into n because this is the same size of the DP plus n. This is a recursion stack space. Okay, so that is why the total time complexity is 2 to the power n and space complexity is this. Okay, so I hope you understood the code and the time and space complexity. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. And for our better understanding, I have also brought down the code here. Okay. Now, since the example which I have taken here is a bigger one, and it will take a lot of time to do the dry run, so I'm just uh, killing it to 1 comma 3 with a fees of 1. Okay. And for that, the DP array will look like this: 0 comma 1 and 0 1 2. This is the by value 0 1, and this is the index value. Okay, and everything is initialized with -1, and this row is basically the base case. Okay, I will explain that. Now let's start with the dry run here. So here we can see that we are standing at index 0. Okay, so we have the option of, if you're standing at index 0, with the option to buy only. So if you buy or if you don't buy, so what happens if you buy? If you buy, index is increased and it becomes 0, and this becomes -1 definitely. And if you don't buy, index increases and still it remains this, and it is +0. Okay, now you can either sell or you don't sell. What happens if you sell? If you sell, index increased to 2 comma 1, right? And here we have 3 with us. Okay, and if you can see here, we will be having 3, right? And index 1 we had 3 minus what is the value of phi? 1, right? So it becomes 2. So we have 2 plus 2. If we try to go much more deeper, we are already in the base case. The index is 2, right? When you come here, we see that okay, index is like equals to the length. So from here we just written 0. So in the DP array, the 2 comma 1 is 0. Then here, if you remember, we sold it, right? And this is a scenario in which you don't sell, you just come down, right? With +0, right? Here, this one. Then again, you'd go for the below cases, and you see that okay, we have already reached the base case, so this will return 0. Okay, so the 2 comma 0, 2 comma 0 is written with 0, right? Now for DP of 1 comma 0, which is 1 comma 0, we have to take the maximum of 2 comma 1 and 2 comma 0. Now from here we can see the maximum from 2 and 0 is what? It is 2, right? And when 2 comes here, 2 is called from this particular function, and 2 plus this -1 gives 1, right? I hope you're getting this. So when 2 is returned from this particular scenario, it comes to this function, right? Suppose here it was having -1 and 2 is returned, right? So this adds up to 1, correct? So at DP of 1 comma 0, you will be having 1. Okay, great. Now we will come back to this call here. If you can see, we haven't bought anything, right? So if you come to this particular call and you buy something, it becomes 0. At index 1 we had -3, definitely, correct? Then you try to go much more deeper, right? But you can see that for the 2 comma 0, if you can see the index 2 comma 0, it is not -1 because we have already calculated, so we'll just return from there. Okay, then we will come here, and in this scenario you are saying that I won't be buying anything right now, so it's still 1 and it's still 0. Okay, and again to try to go deeper, then for the DP 2 comma 1, it is already calculated. If you can see 2 comma 1, it is 0, right? So 0 plus 0, so now this will return 0, correct? And this will return 0 plus -3, -3. Okay, now for function 1 comma 1, or you could say DP of 1 comma 1, I have two options: -3 comma 0. Maximum of both is 0, definitely. Now for this function here, 0 plus 0 is happening, so the function of 1 comma 1, gives you 0. Great. Now, when you go back from here, okay, this had written 1 comma 0. If you remember, it returned 1, and 0 comma 0 has returned 0. So maximum of these two is what? It is 1, right? So what will happen? This will have 1 with it. Okay. And after that, we can see the function call is done, right? We have reached here and we returned 1. This profit had 1 with it at the end. So this complete function returns 1. Okay. That is why for this particular 1 comma 3, we have the output as 1. Let's check how 1. If we subtract by 1 and sell it at 3 and subtract the fees, we get 1 is the maximum output, right? So if you have any doubts or confusions about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach, and the code. And also, if you don't have the knowledge of recursion and the DP, please go and have the learning of that. Do a dry run by yourself on 2 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since we are already familiar with the problem and the solution, let's move to the lead code and code the solution. So let's start by taking the length of the array first. Array size of prices, or the length of prices. Then we will create DP, right? It is going to be -1 for in range 2 for in range n. Return self dot helper function or func. We can write it as func starting with the 0th index with the buy option with fee, or you could say prices, fee, and the DP. Okay, so let's write the function here. The index, this is the buy option you have, then you have the prices, then you have the fee, then you have the DP. Now if the index is equals to the length of the prices, we will just return 0, right? If the DP of index and buy, if it is not equals to -1, that means it has already been visited, so we'll return DP of index and buy. Okay, after that we will check if buy, if it is equals to 1. What we have the options? We have the option in profit to take max of minus of the prices of the particular index plus the self dot func, and will increase the index. We will make the buy as 0 so that you cannot buy anymore, you have to sell it. Prices, then the fee, then the DP. Okay, yeah. Then otherwise you just do 0 plus func of, you can write it as self dot func of index is of course increased, buy remains the same, then prices is there, fee is there, the DP is there, right? Great. Let me stretch it a little bit. Great. Otherwise, you have the option of profit to take the max, right? Prices of index, subtract the fee amount, then you call the self dot func index plus 1. Since you sold it, right? So you are allowed to buy, so it will become 1. Prices, then fee, and then DP. Otherwise, if you don't do anything, it will be 0 plus self dot func. You will just increase the index plus 1, 1. Then will remain 0. You cannot buy because you have not sold anything, right? Prices, fee, comma DP. After that, in the DP of that particular scenario, DP of buy here, it will be the profit. We'll just return the profit. Okay. Let's try submitting for the sample test cases first. There is an error here because it has to be self. Let's try again. Okay. Now let's finally submit the solution. So we have successfully submitted our solution. Now Code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.